Hello everyone, welcome to Scholar Lab. Our simulations can transform your teaching approach, making lessons much more interactive and captivating for your students. Scholar Lab is a distinctive virtual laboratory that brings intricate STEM concepts to life through engaging simulations. This tool is crafted to aid students in comprehending and applying scientific principles in practical situations. Welcome to a hands-on journey where students can explore the fascinating world of magnetic fields and electromagnetic induction. Through this interactive simulation, they learn how moving magnets, coils, and wires can generate electric currents and understand the principles behind AC and DC generators. Whether it is generating eco-friendly electricity or observing the direction of induced current. This lesson will bring electromagnetic concepts to life. Let's dive into electromagnetic induction and generator simulation. Each simulation begins with the game plan. This outlines the overall procedure, observation, and learning of the simulation. If you are a new user, kindly go through this section thoroughly to maximize your experience. Our main objective is to explore and understand the concept of electromagnetic induction and the working principles of electric generators. Before getting into simulation, you can use your mouse cursor by click, hold and drag. You can view our physics lab in 360-degree angle. Or else you can use this bottom right button to view that in 4 different angles. T for top, F for front, R for right and L for left. This simulation is divided into 3 important parts. The first part is electromagnetic induction. Under this we have 2 categories, coil and magnet and straight wire or magnet. Let's start with coil and magnet. Here we have coil and another side we are having a magnet. You can clearly see the magnetic field, it's pictured in red lines. You can click on this button to hide the magnetic field lines. Now we are going to insert cylinder to the coil by clicking on the center button, insert cylinder. Or else you can remove it whenever you want. These 3 buttons, low, medium and high, will come into play. First let me click on low and observe the changes. You can observe the changes in galvanometer when the magnetic comes closer to the coil. Let me click on medium. It shows 10. What about high? It's more than 10. It's nearly goes up to 20. Now let me click on swap polarities and observe the changes. For low, as you can see, as the polarity changes, the galvanometer reading is also getting changed. Similarly, you can observe it for medium as well. And what about high? As you are swapping the polarities, the needle shows the opposite side. You can try out few more things in this simulation, that is increasing the magnetic size. Let's observe how the size of the magnet effect on this meter. Let me try it with high. Did you observe the changes on the meter? Let's increase the turns and observe the changes. I just increase the turns of the coil and locking the movement of the magnet, and let's observe how low, medium and high the distance affects the meter. The inference is given over here. When a solenoid moves towards the bar magnet or vice versa, a current is induced in the coil. This is explained by the Faraday's law of electromagnetic induction. And the factors affecting the magnitude of the current are strength of the magnetic field, speed of the relative motion, and the number of the turns in the coil. You can also try it out with medium and high as well. It goes nearly up to 30. Now you can try it out with by inducing the cylinders and locking the movement of coil and the magnet. Now let's move on to the second part, that is straight wire and magnet. Here the magnetic lines, how the polarity varies, is also given over here. By clicking on these low, medium and high, this will affect on the meter given on the left hand side. And this arrow mark will move the needle, and according to that the meter varies. You can click on increase or decrease the magnetic size by clicking on this button, and by clicking on swap polarities you can observe the changes. According to that, the law is also getting changed. When a straight moving wire intersects the magnetic field lines, it induces a current in a wire, as you can see here. However, when the wire moves parallel to the magnetic field lines, no field lines are intersected, resulting no induced current. As you can see, it is not inducing any type of current. But when it is non-parallel, it is inducing the current that is measured by this meter. Let's move on to the second part of the simulation, that is generators. Here we have AC and DC current. Let's start with AC. By clicking on this rotate arrow, the rotation will start. You can click on the color mode to see that in different color, that is purple here, and as it starts rotating because of the magnetic field and the current, the galvanometer is also getting changed. By swapping the polarities, you can observe the change in the motion, current and field law, that is Fleming right hand rule and left hand rule. What about increasing the magnetic size? As you can see, it is much more than the lesser size of magnet. Let's move on to the DC current. I'm clicking on rotate L to start the rotation process. The meter shows how much the current is produced over here. You can click on the color mode to observe the color. An increase in magnetic size will also shows the effect of current produced due to the size of magnet. The meter clearly states that in contrast to AC generated, a DC generator produces the direct current, a current that flows in only one direction. In case of AC, we observe that in both the directions, isn't it? Here, the students will build a working model of DC generator using these magnets and based on the Fleming right and left hand rule. Let's move on to the next part of the simulation, that is quiz. Quiz will give you the analysis of how much students have understood the concept. Here we have set of 5 questions, and these 5 questions based on the simulation concept. All these 5 questions must be answered before hitting on last submit button. By clicking on submit button, you will get to know about your scores, and clicking on the check answers, it will show you the correct and wrong answers of these 5 questions. Also, you can click on the explanation button to view the solution of the question. In this engaging and interactive simulation, students will explore the fundamental concept of magnetic fields, electromagnetic induction, and the working of AC and DC generators. Through this real-time visualization, they'll understand how electric current is generated when conductors move through a different magnetic field. They'll also apply this Fleming right-hand rule to predict the direction of induced current and learn about the real-world applications of these principles. By the end of this simulation, students will have a solid grasp of how magnets, wires, and coils work together to generate electricity, and how these principles power the world around us in an environment-friendly way. Happy learning! Thanks for watching.